Now students, next topic is reflection of a wave from an open boundary. Now we will consider here that we have a string which is now attached to a boundary or to an end in which a ring is attached. Let us say that a ring is attached to this boundary, and we have given a sudden jerk to this string such that the wave travels in this direction. Okay, now as soon as the wave will reach this boundary, what will happen? Now this ring is allowed to move up and down. Yes or no? There are no restrictions on this ring. It can move up and down. So here in this case, this boundary will kind of act as a rarer end, and this will act as a denser medium. Fine. So as soon as the wave will now hit this boundary, the ring can move up and down, and hence the speed in this medium will be greater as compared to in the rarer medium, and therefore there will be no phase reversal here. Okay, after reflection also, now the wave will move along the same path but only in opposite direction. Is it clear? Okay, it is moved in the same path as it was earlier, moving as a crest. Similarly, after reflection also, if this is a reflected wave, after reflection also it will move along the same path but in opposite direction. Okay, and that is why this is also known as a free end or an open boundary. Is it clear? So we can say that there is no friction present, and that is why the ring is allowed. It is like it can slide without friction up and down along a vertical rod. Okay, so crest is produced in the string at A, it reaches the end B, and it meets little or no opposition there, and this is the reason the ring rises above its equilibrium position. As the ring moves up, it stretches the string and produces a reflected crest, as you can see over here, which travels back towards A. Therefore there is no phase reversal in this case, and we can say that crest is reflected as a crest. Is it clear? Okay, so we can say when a traveling wave is reflected along an open boundary, it suffers no phase change. But you have seen in the previous case, in a closed boundary, it suffers phase reversal of pi radians or 180 degree. Is it clear? Now this is the theoretical part. Now if we consider the incident wave, if we represent an incident wave, if you remember the case for a closed boundary, if we consider an incident wave, we know that y depends on, it is a function of x comma t. Is it clear? This is the x axis, the direction of propagation of wave, and y and t is the time. Okay, so it is represented by, let us say, a sine omega t minus kx. Now if you remember the first case for rigid boundary, now for rigid boundary, if we consider, then reflected wave x comma t, how can we represent it? If you remember the rigid boundary case, that the reflected wave, it travels in opposite direction as well as it suffers a phase reversal. Okay, so first of all, as it travels in opposite direction, this is the positive x direction, this is the negative x direction. So first of all, we'll get a negative sign over here along with a sine omega t. Now there will be minus or plus. If you remember, in case of displacement of a progressive wave, I have told you that if a wave travels along positive x-axis, it will have equation a sine omega t minus kx. Whereas if it travels along negative x-axis, now it is traveling along negative x-axis, so it will have wave equation omega t plus kx. Phase will be represented by omega t plus kx. So the reflected wave for rigid boundary, the equation for the reflected wave will be represented by yr x comma t minus a sine omega t plus kx. But for open boundary, there will only be change as there is no phase reversal. So no negative sign will come, or there will only be change. The equation will be a sine omega t plus kx. Now here only the change is due to the change in direction. First of all, it was moving along a positive x-axis. Now it is moving along negative x-axis. So due to this only there is a change in phase, which is a sine omega t plus kx. Fine? Is it clear to everybody? Now, in case of reflection from a rigid boundary, as I have told you, we can say that the incident and the reflected pulses, they meet in opposite phases. Somewhere they will meet in opposite phases, and at the end point, suppose if I explain you like this is the rigid boundary, and one wave it is hitting the wall or the rigid boundary here, and same from here only another phase reversal occurs and another wave starts. Okay, so this reflected wave starts. So we can say that at the end points, the reflected and incident pulses, they meet in opposite phases. This is one and this is the opposite phase. So they meet in opposite phases, and so they cancel each other. And hence a node is formed here in this case, where at the boundary. Okay, therefore we can say that the net displacement is 0 in this case. Is it clear? Now if we consider the reflection from an open boundary, we can see that the incident and reflected pulses, they meet in the same phase. Yes, as you can see, once it is going across this positive x-axis, yes, it will come here, hit the boundary, and from here only another pulse, it will hit the boundary, and from here only another pulse will start. Yes, so in one way you can see that here overlapping occurs. Is it clear? So here in this case, the incident and reflected pulses, they meet in same phase. And that is why we can say that they reinforce or get added to or superpose each other. Okay, hence in this case, when these two wave pulses, they reinforce each other, an antinode is formed. At the boundary. Okay, that means that displacement will be maximum in this case, and displacement will be equal to twice of the amplitude of either pulse. Both the pulses are of same amplitude, so any of the pulses you can take, and its twice of the amplitude will be equal to the displacement in case of an open boundary. Okay, so through this you have seen that For a rigid boundary, a node is formed at the boundary as due to phase reversal both the wave pulses they meet at the end point at this this fixed boundary, and hence they cancel each other and net displacement becomes zero, so a node is formed. Whereas in case of an open boundary, both the wave pulses they meet in same phase and they reinforce or superpose each other, and hence an antinode is formed, and the displacement in this case will be maximum, and it is equal to twice of amplitude of either pulse. Okay, I hope this is clear to you. In the coming topics you will get more understanding about nodes and antinodes.